You've written a loop that loops over values and finds the best fit for some property, such as largest negative, smallest number, or longest string, but the code isn't working. Maybe it shows you the wrong value, or maybe it crashes at some point during the loop. What's going wrong? This is Maggie from Design Code Debug Repeat. I'm going to show you the 7 most common errors I see with this best fit looping pattern and how to fix them. Let's get started. I have a working program here. I'm just going to run it to show you how it works. The program says it's going to find the largest value I enter, then prompts for a positive value or -1 to quit. I'll enter 1, 10, 5, and then -1, and it tells me the largest value entered was 10. Now, in this example, I'm using Python to find the largest integer entered by the user in a sentinel loop. But the pattern and most of the errors are the same in any language, finding any kind of best fit, and whether you're obtaining input from the console, from a file, or iterating over a collection structure, such as a list or an array. Let's look at the first error. This is error1.py. I'll run the program and enter the same values. And the program tells me the largest value entered was 10. We'll need to test a little more thoroughly to find the error. When we're looking for a best fit value in the input, we should test edge cases, such as the best fit value appearing at the beginning of the input. I'll enter the 10 first. The end of the input, I'll enter the 10 last. And we should test no input at all. You can see that's where this solution fails. When I immediately enter -1, the program tells me the largest value entered was 0, but of course that value does not appear in the data. To fix that, our program needs to check if any data was entered. With a sentinel loop, we can count the number of values entered with a variable that we initialize to 0 and increment each time a non-sentinel value is entered. After the loop, we can check that the value is not 0 before printing the largest value entered. The next error might be the most common one I see from beginners. I'll run error2.py and enter our original values. And the program tells me the largest value entered was 0. Let's look at the code. With the best fit pattern, or most wanted holder pattern, we have a variable that holds the best fit for the property we're looking for so far. In this example, each time through the loop, it should hold the largest integer encountered so far. In this program, that variable is called best fit. With the sentinel loop, I have a priming read. I'm obtaining a value from the user first, and then I check if that's -1 with while value not equal -1. If it's not -1, then we go into the loop and process the value, and then at the end of the loop we get the next value. Back up to the test. Repeat. In the processing, I'm comparing the most recently entered value, stored in the variable value, to the best fit variable, stored in the variable best fit. If I compare these, and the value most recently entered by the user is now the best fit, then I replace the value in best fit with the value that was just entered by the user. It's very important that we write that comparison correctly. So I've got a mistake here in this program that finds the largest value entered by the user. But no matter what the best fit is, again, it could be largest negative, longest string, smallest odd number, whatever you're looking for, you need to write the comparison so that if the recently entered value is a better fit, we put its value in the best fit variable. And my comparison here is if best fit greater than value. That's almost the opposite of what I want. I want if value greater than best fit. If I swap that around and run it again with the same inputs, now it correctly finds the 10. So whatever comparison, make sure you're writing it so it evaluates to true if the recent value is a better fit than the value in the best fit variable. Error 3 is a related error that I also see pretty often with beginning programmers. Let's run error3.py and enter our usual values. And again, we get a result of 0. Let's step through this one in the debugger. With a loop, it's often easier to see what your code is doing if you walk through it yourself with pencil and paper on inputs that cause the error, or step through it in the debugger. I'm going to put a breakpoint at the top of the loop, turn the debugger on, check the source box, and run the program. So I'll press go, and it asks me for a value. This is the priming read executing, the line of code before the loop header. I'll enter 10. And now I'll press the over button on the loop header, and we go into the loop because 10 is not the sentinel value. And I'll press the over button on the line of code that counts valid inputs. Now we're on the comparison, if value greater than best fit. That is written correctly, we know from fixing error2.py. This test will be true if the value the user just entered is larger than the best fit value so far. In the debug window, we can see the value the user just entered is 10, and the best fit so far is 0. So I'll step over, and as expected, we execute the assignment statement. Let me step over it while you pay close attention to the variables. Did you see what happened? Instead of replacing the value in best fit with the value the user just entered, the code replaces the value the user just entered with the best fit value, which was initialized to 0. This error is the programmer accidentally replacing the value in the wrong variable, or simply mixing up the order of the assignment statement. The expression on the right is evaluated, and the value is stored in the variable on the left. In the best fit pattern, we want to replace the value in the best fit variable with the value most recently entered by the user. When I fix that assignment statement, run it, and enter our usual inputs, we get 10 again as the largest value entered. Let's look at the next error. This is, again, another common error that I see. I'll run error4.py and enter the usual values, and it says the largest value entered was -1. That's the sentinel. Let's take a look at the code. Do you see the error? Instead of printing the best fit variable, I'm printing the value variable, so that will always print the last value entered by the user. If it's not a sentinel loop, for example, if we always ask the user for 5 values, this will always print the last value entered. Sometimes that might be the largest value, so it can sometimes be a tricky error to find. And it's an easy error to make, especially if you're changing variable names as you're programming and you're focused on the loop and not the output statement so much. I see this all the time with all kinds of programs. A student has worked really hard and gotten their code computing correctly, but then has displayed the wrong result. Let's look at error5.py. When I run the program, you can see I've switched it up a little, and the program is now going to report the smallest value entered. Let's enter our usual values of 1, 5, 10, and -1, and we expect the program to tell us that 1 is the smallest value we've entered. But it doesn't. It tells us 0, and we never entered 0. Let's look at the code. You can see that I've changed the test inside the loop, so it's if value less than best fit, which is correct. We want to replace best fit with what's stored in value if value is smaller, making it the best fit so far. And the assignment statement is correct. The error here is that I didn't give the best fit variable an appropriate initial value. We want to ensure that the first value the user enters is the best fit the first time through the loop. To do that, we need this test to be true the first time through the loop. So if I'm looking for the smallest number entered by the user, no matter what they enter first, the test, value less than best fit, must be true. That means that best fit must be a very large number. So whatever the user enters will be smaller. There are a couple of strategies you can use here. We can set best fit to something really large, like sys.max size, which is the largest integer in this Python installation, and which we can get by importing the sys module. Or if we know our inputs well, we can set it to a number that is larger than any possible input. For example, if the user is entering human ages, we know that an age is unlikely to be more than 120. So we could safely start our best fit variable out at 200, for example. Another strategy is to store the first value entered by the user in best fit before we start looping, then get another value from the user and loop. So in this program, obtain the value, and if it's not -1, store it in best fit, increment the number of values, and then get a value and start our loop. Error6.py also finds the smallest value entered by the user. I'll run it and enter our usual values, and it tells me the smallest value I entered was -1. Technically, that is true, but -1 is supposed to be the sentinel and should not be processed. If you look at the code, you can see there is no priming read before the loop header. Value is set to 0 so that we enter the loop the first time, and then we immediately obtain a value from the user and process it, regardless of whether it's the sentinel or not. You can avoid this two ways. One is to check, right after we obtain the value, that it's not the sentinel, and if it's not, then we can process. That will avoid processing the sentinel. But I recommend using the loop structure that I have in the other examples. A priming read, which is the initializer for our loop control variable, then the test, processing at the top of the loop body, and then the updater at the end of the loop. That way, we are giving the loop control variable its new value immediately before the test every time through the loop. We will never process the sentinel. Finally, we get to error 7.py. This is another error I see all the time in many different kinds of loops. And this is an error that will only show up in certain test cases. We're back to a loop that finds the largest value entered by the user. I'm going to enter 1, 10, 5, -1, and it tells me 10 was the largest value entered. Correct. The largest value was in the middle of the inputs. Let's try the edge cases with it at the end. That works. And the beginning. And that does not work. The program tells me the largest value entered was 5. And here's the code. Do you see the error? I read the value in a priming read before the loop, but then I immediately read a new value at the top of the loop. So we're never processing that first value entered by the user. This is an off by 1 error, but a sneaky one. To fix this, of course, we put our updater at the end of the loop. We need to process that value entered in the priming read at the top of the loop. We'll get the new value at the end of the loop and process it the next time through, if it's not the sentinel value. Now, if your loop is actually crashing with an exception, chances are you're iterating over a list and you've tried to read beyond the index of the last element. A classic off-by-1 error. Adjust your loop exit condition so you're not entering the loop when the index equals the length of the list. So there you have it, the 7 most common best-fit loop pattern errors that I see as an introductory programming teacher. Please drop a comment below if you're familiar with an error that I've missed, or if you have any questions or comments about the errors I've shown here. As always, have fun and keep coding.